I have spent the last 3 decades working with legacy systems, but this one was in worse shape than most projects I have ever worked with. I was sure an AI agent would just make things worse. But thanks to a mindset shift and 3 techniques I discovered as a result, I managed to pull off a project I estimated would take me months in just 5 days. So let me show you the techniques that made this possible. My mindset shift started in July. As a technical coach, I was invited to the Sama Society's yearly open space, where we discussed how we can do our work more effectively. This year, not surprisingly, there was a lot of talk about coding with AI agents. Not just talk, we also played around with the tools and experimented with techniques. Before that, I was very skeptical about AI agents. I felt they were making too many mistakes and just slowed me down. But during that event, I realized that working with these tools isn't just about prompting them right. Instead of getting annoyed, I started trying to understand the root cause of the failures and find ways to help the AI to do a better job. In a sense, I started to treat the agent as an engineer I'm coaching. When I returned home, I started building things with Claude Code. Starting a new project felt like magic. I explained what I wanted, and a couple of minutes later, it's done. But that initial productivity gain quickly gave way to debugging long and complex functions. I often got frustrated and asked the agent to refactor. But then I noticed something weird. By refactoring, it noticed the bug in the implementation and fixed it. I didn't even have to help it anymore. That got me thinking. If all I have to do is tell the agent to refactor long functions, why not automate that? All it takes is a detection script that runs as part of a hook and prompts the agent to refactor. It is like a habit, an action taken in response to a trigger. So I call these scripts habit hooks, automated prompts that trigger on specific code smells. I even made a deep dive on it if you want the details. But can it handle a legacy system? I wanted to find out. So I decided to try an experiment. And what better opportunity than the code I previously decided not to touch despite the huge financial incentive. The codebase I mentioned in the intro was running on Heroku, and the per gigabyte cost of MongoDB is significantly higher than a comparable SQL database. But the database calls were directly in the HTTP endpoints. Functions were long and hard to follow, and there wasn't a single test to find. I knew this wouldn't work as a one-shot prompt, so I solved one problem at a time. Starting with tests. I needed a lot of them, and I didn't have months to write them manually. But when I asked the agent to write them, it generated every single one with very different structures. There were lots of redundancies, while still having parts not covered at all. I almost gave up when I realized something important. I don't need to test the whole system for the migration to work. The only thing I need to show is that the new database layer does the exact same thing as the old one. And therein lies an opportunity. I could create a test framework constrained enough that all I had to check was coverage. I introduced the delegation layer with the same interface as the existing database layer and made every single test go through it, including setups and teardowns. Now, here is the cool part. The delegation layer can switch between the old and the new database, which means every single one of my tests are actually 2 tests, one for the old database and one for the new one. If the test passes with the old database, I know that the test is correct. If the correct test passes with the new one, I know the new database is correct. Okay, I still had to manually validate the tests, but because they had a uniform structure with assertions baked into the framework, it took minutes instead of hours. The key insight is this: create a domain-specific language that constrains what tests the AI can write. Make it hard to write bad tests and easy to validate the good ones. In practice, I now use data providers to drive a single test with external files, mostly markdowns. So now I had tests I could trust. But I had one other problem to solve. Remember those direct data access calls inside the HTTP endpoints? So Claude Code and I started extracting database calls one by one. The pattern was simple. Wrap the call, move it to a service layer, rinse and repeat. After doing a few together, I asked the AI to handle a couple more, and it did them perfectly. So I pointed it at an entire collection and let it rip. Then came the actual migration. Me giving guidance, the AI planning, me adjusting the plan back and forth. It was grueling, honestly, probably slower than doing it manually. But I made one crucial decision that saved everything. After every step, I asked the agent to document what we have been doing. 3.5 days in, we finished the first database collection, and I had this massive markdown with 6 detailed steps, from identifying and refactoring database access to writing tests and migrations. I was exhausted, questioning if this experiment was worth it, but I committed to one more collection to see if the documentation would actually help. My prompt was simple: review migration process MD and complete step 1 for the messages collection. This time I only had to correct the AI a few times, but each time I asked it to document what it learned. In a few hours, we were done, and the process got better too. I handed Claude the third collection. This time it did it with zero intervention. I almost couldn't believe it. By the end of day 4, 3 collections were done. At this point, I decided to take a gamble, and I let the agent loose without supervision. I spun up a Git work tree for every remaining collection, fired up a Claude instance for each, and went to sleep. But the next morning, the agent proudly announced that the migration was done and all tests are passing. And I spent the day reviewing the code, testing the app, and chasing down the few bugs that the agent didn't catch. But by the end of day 5, we ironed out the remaining kinks. It still took 2 more days to actually release and run the migrations in production. But the meat of the work, the hard part, was done in 5 days. Remember the open space where my mindset shift began? One of the people there was Lada Kessler. Recently, she started collecting patterns that make working with AI agents more effective. I joined her effort, and we have created the Augmented Coding Patterns website that contains over 40 patterns today. 3 of them are my 3 key ideas for this project: habit hooks, constraint tests, and finally, show the agent, let it repeat. The website fills a crucial gap by providing actionable guidance on how to get more out of AI agents like Claude Code. Links in the description. But before you rush off to rewrite your entire legacy system with AI agents, I need to give you a serious warning. Rewrites can end companies. Remember Netscape? In the 90s, their name was synonymous with the internet. Yet when they decided to rewrite their browser from scratch, it ended the company. If you want to know the 2 critical factors to rewrite safely, watch this video next. It breaks down the exact system I use for any serious rewrite project. Thanks for watching, and I see you in the next one.